So first question is, which type of atomic bond involves the delocalization of electrons across a lattice and is characterized by high thermal and electrical conductivity? Option A covalent, B hydrogen bonding, C ionic bonding, and D metallic bonding. So let's look at what the answer and its reason. So these are the main three types of bonding: ionic bonding, covalent bonding, and metallic bonding. And given is the reason, basic the principle or reason happening in these three bonding. So if you look at the ionic bonding, it's a bad conductor of electricity because the ions are held tightly together by the force of attraction. So that's the only thing to keep in mind for ionic bonding. On the other hand, covalent bonding is also a bad conductor, and we know the bond is formed due to sharing. Okay, so it will also be a bad conductor. And final, metallic bond is a good conductor because the electrons are free. That is what mentioned in the question, because delocalization of electron means so much electrons are free. So delocalization of electron, so because electrons are free, so that's in the case of metallic bonding. And so that's the case of metallic bonding. And also checking the thermal conductivity, ionic bonding is a very low thermal conductivity. And what is covalent bond is having covalent bond is also having very low thermal conductivity, but metallic bonding is having good thermal conductivity. So according to your question, we have good thermal conductivity and good conductor is a metallic bond. So the answer is metallic bonding. So next question is, when comparing ionic and metallic bond, which of the following is a distinguishing feature of metallic bond? The transfer of valence electron between the atom, formation of lattice structure by cations surrounded by a sea of electrons, the presence of direct bonds forming molecular structures, occurrence primarily within the compounds of non-metal. So among these, option B is correct, because option 1 we know the transfer of valence electron between the atom occurs in ionic, and then option B, the formation of lattice structure by cation surrounded by a sea of electron. We know for a metallic bond the main feature is a delocalization of free electron, right? So the lattice structure is surrounded by a sea of electron. So comparing according to this question, compare ionic and metallic bond, the distinguishing feature of the metallic bond among these option is option B, the formation of lattice structure by cation surrounded by a sea of electrons. So what describes the relationship between the lattice parameter A and the atomic radius R in a simple cubic lattice? So we know the relation between the edge length A and R of there are different lattice arrangement, right? Simple cubic lattice FCC, BCC. So what you have asked is to find the relation between A and R for a simple cubic lattice. Option A is 2R, option B is A is equal to 4R, option C A is equal to R by root 2, D A is equal to R root 2. So among this, the answer is A is equal to 2R. So how does it get the answer A is equal to 2R? So this is a simple representation of how these lattices are arranged. Atoms are arranged in a simple cubic lattice. We have the sphere is represented by each atom, which is stacked in each corner, and you will be having radius r, right? So that both atoms are meeting exactly at the center of each edge length. So the edge length A is formed by the radius of both the atoms from both the corners, r and r of each one. So r plus r 2r. We know in simple cubic lattice only the atoms are arranged at each corner. So among these corners, this is the front view. How does an atom get arranged? Okay. So next question for those in a face-centered cubic crystal, which of the following plane will exhibit highest planar density? So we have to find which of these Miller indices plane representation will have higher planar density. So we have 1 0 0 1 1 0 1 1 1 2 1 1. So based on the given indices, its actual figure, the structure will give us which one have the more planar density. I'll show a few example like. So this is the structure for a 1 1 1 Miller indice structure. This is a cubic crystal structure. So it has more planar density compared to remaining 1 1 0. So it has more planar density compared to, because in unit area it has more number of atoms. Here 1 1 0. So there is one atom missing as compared to 1 1 1. so it has less planar density compared to 111. And next one is 100, so it will be only in one plane, and also 211 will be out of this plane. So compare among all these, the one having more planar density is 111. Which crystal system is characterized by three axes of unequal length with two axes meeting at an angle other than 90 degree? So A orthorhombic monoclinic and triclinic and tetragonal. So among these, with the answer is monoclinic, because A is equal to B is equal to not equal to C. That means all are unequal length, and only two of the angle 90 degree, and the third one is other than 90 degree. Alpha is equal to beta equal 90 degree, not equal to gamma. So it is monoclinic.